Modern enterprise IT infrastructure generates over 100,000 events per second. But the primary bottleneck in processing this telemetry isn't the sheer volume of data. It is the extreme structural heterogeneity of that data. A single network might produce BSD syslog messages, binary Windows event logs, these disparate formats simultaneously, they inevitably bottleneck and drop packets. Simply collecting this raw data without structural normalization creates an unsearchable data swamp. It defeats the very purpose of security intelligence. To solve this, NXLog was engineered as a multi-threaded, non-blocking I/O routing engine specifically designed to normalize telemetry data. Its core architectural thesis relies on strict isolation. Data ingestion, transformation, and forwarding are separated into distinct operational blocks. Because the architecture is strictly decoupled, it allows for the parallel processing of completely incompatible operating systems and formats. This strict decoupling of inputs and outputs establishes a programmable telemetry fabric. The input layer is the first phase of this fabric. Its specific role is extracting data natively from the host operating system before any transformation occurs. For Windows environments, this is handled by the IM-MS VistaLog module. Instead of relying on secondary text exports, this module directly reads binary.evtx files using the native Windows API. This provides a massive forensic advantage by resolving security identifiers into human-readable account names directly at the point of ingestion. On Linux environments, the ingestion logic shifts to the IM Linux audit module. This captures logs directly from the kernel via custom audit rules. It entirely bypasses the need for user space software like auditd. For environments requiring agentless collection, the IMWS Eventin module natively handles Windows event forwarding. By utilizing native OS-level ingestion modules, you eliminate the massive CPU overhead associated with running disparate third-party agents on every single server. Once ingested, the data enters the extension modules. This is the central processing layer, where unstructured text is molded into queryable data. One of the most common engineering headaches here is the multi-line stack trace. When an application throws an error across fragmented lines, it easily breaks standard SciEM parsers. The structural fix for this is the XM multi-line module. It uses strictly defined header and footer logic to identify fragmented logs and stitch them back together into a single payload. For data flattening, the engine uses the XM JSON module. It parses deeply nested JSON structures, flattens them into standard dot notation fields, and strictly enforces UTF-8 encoding validation. Similarly, the XMW3C module can automatically parse IIS logs by dynamically reading the field headers. Executing this rigorous parsing at the edge, directly inside the forwarder, drastically reduces the compute and licensing burden on the central CM. But even with perfectly structured data, a high-throughput pipeline is still bound by network physics. When the destination network congests, the system must respond. Simply dropping packets under heavy load is unacceptable for enterprise compliance standards. The system requires strict flow control. NXLog addresses latency and network congestion using the PM buffer processor module. It executes prioritized processing. During a traffic spike, the system protects critical TCP streams by physically caching lower priority UDP messages to disk. Once the TCP spike subsides, the disk buffer smoothly empties the cached UDP messages back into the main processing pipeline. This hardware-level conditional buffering at the edge guarantees message durability. It prevents total CM blindness during catastrophic network outages. The final phase of the pipeline is the output layer. Here, normalized data is routed to its precise destination. Using the Elasticsearch module, the engine executes direct CM ingestion, completely bypassing the need for intermediate Logstash servers. When facing wide area network constraints, the batch compress module steps in. It preserves limited bandwidth by transferring log data across the network in highly compressed batches. Eventually, enterprise deployments hit a programmability threshold. This is the precise point where standard configuration modules are no longer sufficient to handle complex edge cases. This is resolved using programmatic modules like IMGo, XMPython, and Ruby. These modules allow DevOps engineers to inject custom scripts and external logic directly into the live NXLog execution path. Integrating custom logic natively creates a Turing-complete framework for advanced data pipelines. At a macro level, deploying this architecture creates a new logistical challenge, managing 10,000 independent instances of a pipeline across a global network. Requiring manual node intervention every time a correlation rule or TLS certificate needs updating carries an unsustainable operational cost. The enterprise solution for secure remote administration is the XMadmin module. It enables secure SOAP and JSON SSL connections, allowing an administrator to push centralized configurations to the entire fleet simultaneously. Remote centralized management acts as an absolute prerequisite for maintaining security compliance and agility across a massive distributed enterprise. From chaotic endpoint noise to perfectly structured security intelligence, the pipeline requires precise execution at every stage. The decoupling principle is what makes this possible. Inputs, data structures, and outputs are engineered as independent, infinitely interchangeable variables. A modular architecture is the only way to natively resolve the extreme heterogeneity problem found in modern IT environments. A well-architected telemetry fabric functions as an engine that derives clarity from raw infrastructure noise.